Welcome to WDD's HotSpot. I'm Jennifer Hooker, Editor-in-Chief, and in this week's episode we have System captures fresh water from power plants, 3D printer can now print thicker materials, and Microsoft tests underwater data center. New technology devised by MIT engineers could provide a low-cost source of drinking water for parched cities around the world. About 39% of all the fresh water withdrawn from rivers, lakes, and reservoirs in the United States is earmarked for the cooling needs of electric power plants that use fossil fuels or nuclear power, and much of that water ends up floating away in clouds of vapor. However, the recently developed system could save a substantial part of that lost water and even become a source of clean drinking water. When air that's rich in fog is zapped with a beam of ions, the water droplets become electrically charged and can be drawn toward a mesh of wires that resemble a window screen, placed in their path. The droplets then collect on that mesh, drain down toward a collecting pan, and can be reused in the power plant or sent to the city's water supply system. The equipment is simple and the amount of power required is minimal, but it could have a large impact on the community. Typically, 3D printers have only been able to function using low viscosity materials. However, researchers from Purdue University have changed that with a new technique. By applying high-amplitude ultrasonic vibrations to the nozzle of the 3D printer itself, the team was able to solve a problem that has plagued manufacturers for years. It's now possible to 3D print extremely thick materials that have a consistency of clay or cookie dough with fine precision. By vibrating the nozzle in a very specific way, the team was able to reduce the friction on the nozzle walls so that the material just snakes through. The Purdue team has been able to print items with 100 micron precision, which is better than most consumer-level 3D printers, while maintaining high print rates. This development may enable the creation of customized ceramics, solid rockets, pharmaceuticals, biomedical implants, and more. The first practical application being explored is for solid rocket fuel, which is very difficult to print because it cures over time and is also very sensitive to temperature. But with this method, the researchers were actually able to print strands of solid propellant that burned comparably to traditional cast methods.
Microsoft has created Project Natick, which is trying to keep data centers cool by placing them underwater and pumping cold seawater through the system. Phase 1 consisted of a 10-foot-long prototype that was submerged near the California coast for 105 days. The 2015 test proved the concept was feasible. Now, Phase 2 has started, where the company deployed a data center off the coast of Scotland's Orkney Islands. The new facility measures 40 feet and contains 12 server racks with 864 servers. The main goal of the project is to have a self-sustained underwater system powered by offshore wave, wind, or tidal generators. This means they could be submerged near any coastal city and supply faster internet and cloud service. The team will monitor Phase 2 over the next 12 months to measure performance, power consumption, and temperature. That's all for this week's episode. Be sure to check in on Facebook and Twitter and catch past episodes at wirelessdesignmag.com. For the WDD channel, I'm Jennifer De La Osa. Thanks for watching.